In August 2018, one of the most ambitious and bold solar system exploration projects ever undertaken was launched, the Parker Solar Probe. Aboard the powerful Delta IV Heavy rocket, the probe began an unprecedented journey to the heart of our system, the Sun. For decades, getting so close to our star was considered impossible, then extremely difficult. But today, thanks to advanced engineering and scientific perseverance, humanity has taken this extraordinary step. The technologies we have developed are so advanced that the Parker Solar Probe is able to withstand the hellish conditions of the solar corona for several years, getting closer to our star than any human-made object before. In this video, you'll discover not only if this engineering marvel has truly reached its orbit around the Sun, but also what groundbreaking data it has already sent back to Earth and how they could forever change our understanding of the star that sustains us. A tribute to Eugene Parker. The probe is named after the legendary astrophysicist Eugene Newman Parker, who in the 1950s first proposed the existence of the solar wind, a constant stream of charged particles emitted from the solar corona that travels through interplanetary space. Until then, the idea that the Sun could continuously emit such particles wasn't taken seriously. Today, we know that this phenomenon is responsible for a myriad of effects, from the auroras to geomagnetic storms that can interfere with communications and Earth satellites. The Parker probe, the first space object to be named after a person still alive at the time of launch, is a living tribute to his pioneering discoveries. An unprecedented mission. The Parker Solar Probe is designed to approach the Sun closer than any other probe before it. Previous missions, like the Helios 1 and Helios 2 probes of the 1970s, got as close as Mercury's orbit, about 58 million kilometers from the Sun. However, these missions observed the Sun from what was considered a safe distance. The Parker Solar Probe, on the other hand, will push to within just 6 million kilometers of the solar surface, directly traversing the corona, the outermost layer of the solar atmosphere. A feat never attempted before. To put it in perspective, imagine approaching a campfire. While keeping your distance, you can feel the heat without danger, but if you get too close, you risk being burned. The Parker Solar Probe, with its highly sophisticated heat shield, is the equivalent of a hand reaching toward the fire without getting burned. The difference here is that the fire is a furnace reaching temperatures over 1,200 degrees Celsius. The masterpiece of technology, the heat shield. The core of this extraordinary mission lies in the probe's ability to survive these extreme temperatures. Its heat shield, known as the Thermal Protection System, TPS, is one of the most advanced technological developments ever created. About 2.4 meters wide and 18 centimeters thick, the shield is made of layers of carbon fiber composite and white ceramic materials designed to reflect heat and protect the scientific instruments on board. This shield allows the probe to maintain relatively mild internal temperatures, even while immersed in an environment far exceeding the melting point of most Earth-based materials. Although the shield protects most of the probe, some instruments, such as cameras and sensors, are designed to peek beyond the shield to gather crucial data on the extreme environment of the corona. The probe also uses retractable solar cells, which can fold back to avoid overheating as Parker gets closer to the Sun. Why is exploring the Sun so important? The Sun is the heart of our solar system, the energy source that sustains life on Earth. However, it is also an unstable star, prone to powerful explosions of energy in the form of solar flares and coronal mass ejections, CMEs, which can send vast clouds of charged particles toward Earth. These events, known as solar storms, can damage satellites, disrupt communications, and even threaten the global power grid. The most intense solar storms can have devastating effects. One of the most famous is the so-called Carrington event of 1859, a massive geomagnetic storm that illuminated skies worldwide with spectacular auroras and knocked out telegraph systems. If a similar event occurred today, the consequences for our highly technological world could be catastrophic. Scientists hope the data collected by the Parker Solar Probe will help us more accurately predict these events and mitigate their effects on Earth. Better understanding of the solar wind and the behavior of the solar corona will allow us to protect our infrastructure and prepare our civilization for future solar storms. An extraordinary achievement. The mission's first major success occurred in April 2021 when the probe made a complete pass through the solar corona. During this flyby, the Parker Solar Probe collected unique data on particle flows and sent back stunning images showing the movement of particles within the Sun. This mission has already revolutionized our understanding of solar physics and will continue to do so in the coming years. The mystery of the solar corona. One of the biggest mysteries the Parker Solar Probe is attempting to solve is why the solar corona, the outermost layer of the Sun's atmosphere, is significantly hotter than the star's surface. In the photosphere, the visible layer of the Sun, temperatures are around 6,000 degrees Celsius, but in the corona, these temperatures skyrocket to over 1 million degrees. This phenomenon, known as the solar corona paradox, challenges our current understanding of stellar physics. It's as if the air just above a flame were much hotter than the flame itself, a counterintuitive phenomenon that remains unexplained. The Parker Solar Probe may provide crucial clues to solving this mystery, helping to explain how energy transfers through the Sun and how the Sun's magnetic field influences the entire solar system. An immortal legacy. Unfortunately, Eugene Parker did not live long enough to witness all the results of the mission that bears his name. He passed away in March 2022 at the age of 94, but his contribution to space science and our understanding of the Sun will remain forever. The Parker Solar Probe will continue collecting data until 2025, when solar heat and radiation will likely begin irreparably damaging the probe. Nevertheless, the results obtained by that time will mark a milestone in space exploration, forever changing how we view and understand our star. What do you think about solar exploration? We hope this journey has captivated you as much as it has the scientists working on the mission. Tell us what you think. Do you believe solar exploration is essential for our safety and future? Or do you think the Sun will continue to sustain us without surprises? Write it in the comments, leave a like, and subscribe to the channel.